Hello, I am Dr. Drumin Pandya, author for Invent and Education, India's first and only publisher who has books with physical manipulatives for students. Today in this session, we will see the manipulatives in actions. Basically, manipulatives are different shapes and blocks given to students so that they can understand mathematics better. So I'll start with a simple example, number tiles. So in grade 1, when students join, we start from counting. So the manipulatives can be dragged very easily if teachers are using touchscreen board. If there is no screen in the class, still you can use the symbols like square or a rectangular strip which shows a 10 to show manipulatives. So today I am using Mathigon polypad for this tutorial, but there are many other manipulatives also available, so you can use any platform that you like. Alright, so we have number tiles and cubes with us, in which we have a 1, a 10 and a 100. Now we will try and demonstrate that how come 10 ones make a 10. So I'll take 10 ones here. I can arrange them the way I like. So 1, 2, 3. This one is my 4. This one is my 5. This one is 6, 7, 8, 9 and 10. So these are my 10 ones. Now let's see if I drag a 10 from here. It is of the same length. So my 10 ones are exactly equal to a 10. So this is how we can show how come 10 ones make a 10. Also, these manipulatives can be used to form and represent different numbers. Let us see how. So if I have a number 3, I can drag 3 ones and arrange them to make my number 3. Now, if we want to show number 23, so I have to take 2 tens and 3 ones. So we can have 2 tens here, and with that I will take these 3 ones. So this is representation of number 23. Now if we want to show the number 123, so I can drag 100 here, 2 tens and 3 ones. This is 1, 1, 2, 3. So this will be my representation for different numbers. Next, we will understand addition of few numbers with the help of manipulatives. So a simple addition like 12 plus 23. Now this can be easily shown with the help of manipulatives. So for 12 we have a 10 and 2 ones, and for the second number 23 we have to drag 2 tens and 3 ones. So these are my two numbers, and we add them, we actually count them together. So when I count ones, I have 2 ones here and 3 ones here. So total ones are 5. And I have 1 10, 2 10 and 3 10. So total 3 tens and 5 ones are there. Now this is very useful when we are teaching regrouping. Alright, now let us consider one example in which we have to do regrouping for addition. Now this thing is very tricky, and often we show it like a process which students follow. But if we use manipulatives, we can actually show tens and ones and explain these things better. So I am taking two numbers, say 15 plus 26. Let us consider addition of 15 and 26. Now 15 is represented by 1 10 and 5 ones. 26 is represented by 2 tens and 6 ones. Now when you count them together, you have to count ones. So here I have 6 ones and here I have 5 ones. So what I will do, I will make a 10 with the help of these objects. So I am taking 4 from here, dragging them here. So this is my 6 plus 4, a 10 is here. And now I will replace this 10. I will replace this 10 with a tens block. Now this entire process is done here like 5 plus 6, 11. So when you say 5 plus 6 equal to 11, you have a 10 and a 1. So this is our 10 that we got, and this is our 1 which was left. So now we have 4 tens and a 1, and the process of addition is explained like this, that when you do 5 plus 6, you have a 1 and a 10, and that's why you have 4 tens. So when students can touch and feel mathematics, they understand things well. Rather than explaining this merely as a process, we can have manipulatives and actually show how these things work. Now subtraction is process of taking away. Now we will see with the help of manipulatives how this thing work in action. So for 36 minus 12, I have taken 3 tens and 6 ones to represent my first number 36. Now from this I am supposed to take away 12. So I have to take away a 10 and 2 ones. So I will take away 1 10 from here and 2 ones. So earlier we had 36, I removed this 12 from that. So what is left? 2 tens and 4 ones. So answer is 24. Here we are subtracting 2 from 6 to get 4. We are subtracting 1 from 3 to get 2. Now this concept becomes very, very useful when we are showing regrouping through borrowing, right? So I will consider another example in which we will see how we can show borrowing with the help of manipulatives. Alright, now we will consider another example. Now here we are subtracting 16 from 34. So I have manipulatives which are representing number 34. Now I am supposed to take out 16 from it. That means I have to take out 6 ones and a 10. Now For ones, this is my 1, 2, 3, 4. So I only have 4 ones, I need 2 more. For that, what I will do, I will split this and I will take out 2 ones from it. So now I have 6 ones with me. I will also take out a 10 here, and this will be my answer. So I have 110 and 1, 2, 3, 4, 5, 6, 7, 8, 8 ones. So my answer is 18. Now when we teach the method, we show them how to borrow. So here I borrowed a 10 from 3 tens. So here, because we borrowed, we will write 2 here, and then a 10 was borrowed. So we had 10 ones. So earlier we had only 4 ones, but after that we had 14 ones. Now this process can be very easily shown with the help of manipulatives. If we are not using manipulatives and forcing students to remember this thing as a process, math becomes confusing and at times torturing for students. Alright, now let us see how manipulatives are useful in multiplication. So I am multiplying 23 by 12. So I'll drag a model for this. Now if you consider this side, this is my 10, another 10 and 3 ones. So length of this side, is 23. If you consider this side, this is my 10 with 2 ones, so this side is 12. That means the area of this rectangle should be the result of 23 and 12's multiplication. Now we have 2 hundreds here, so I'll write 2 hundreds. 1, 2, 3, 4, 5, 6, 7, 7 tens and 6 ones. Now let's see the process of multiplication. Can we see different parts here? I'll again write 23 multiply by 12. When we teach this, first we ask students to multiply 23 by 2. So they write 2 3s are 6 and 2 2s are 4. Now this 46 is here. This 46 is here. So we have 4 tens and 6 ones. So this is actually like multiplication of 2 and 23. Now in another part we will multiply 23 by 1, but no, this is not 1, this is 10. So for that we have to put a 0 here and multiply 23 by 1. So this 230 is my this part. This 230 is here, and that's why addition of these two is 276. Now I will consider same manipulative to explain you decimal multiplication, but for that first we need to consider the values and areas of our manipulatives. So I'll clear my screen and set the new example. Now we will see decimals with our manipulatives. So for decimal, I will consider this square as 1. So if the side of the square is 1, its area also will be 1. So I'll write area is 1. Now consider this blue strip. This is 1/10th part of this. So I'll drag it here. This is 10th part of my square. So 1 upon 10, which is 0.1. Now if you see the dimension, it is 0.1 by 1. So area of this rectangle will be 0.1. Now consider this small square. This is 100th part. This is 100th part of my 1. So its area will be 1 upon 100, which is like 0.01, and side of this rectangle is 0.1. So 0.1 multiplied by 0.1 is 0.01. So these are the three areas. Area of this is 1, area of this strip is 0.1, and area of the small square is 0.01. Now based on this, we will do one multiplication. So I'll drag a model. So this is my model. Now what I can do, I can relate it with these shapes given here. So if this side is 1, this side is 1, and this will be 0.3. So this entire side will be 2.3. If this is 1 and this is 0.1, 0.1, so this entire side will be 1.2. So if I multiply 2.3 and 1.2, the area of this rectangle should be result of product of 2.3 and 1.2. Let's see how it works. So 2.3 multiply by 1.2. Alright. Now many teachers will find it odd. Okay, why there is a dot here? Because the way we were taught mathematics, we were supposed to remove this decimal point, then do the multiplication, and then bring the decimal point back. Why? Because there was no answer to it. It was merely taught as a process. But now I'm keeping the decimal point here, and I will show you each and every part here with the help of manipulative. See, this is the magic of manipulative. You can't visualize maths if you are going this way. You have to touch and feel maths in order to learn it better. Alright, so the area of this rectangle is this one, 1, 2, 3, 4, 5, 6, 7. So we have 2 ones, 7 times 0.1, that is 0.7, and 6 times we have 0.01, so that is 0.06. So the area should be 2.76. Now let's see whether we can visualize this decimal multiplication with the help of manipulative. So first, it is a multiplication of 2.3 and 0.2. See, this is my 2.3 and here I have 0.2. So this part, how much this part is? This part is 0.46. So I'll write 0.46. Earlier it was not possible, but with manipulatives you can actually see. Now this is multiplication of 2.3 and 1. So this part is 1 and this is 2.3. So area here is the result of 2.3 multiplied by 1, that is 2.3. And addition of these two is 2.76. Now when you use manipulatives, the decimal multiplication becomes very easy and students will be interested. Not only numbers, these manipulatives are also very, very helpful in visualizing algebra. Now here I am using my manipulatives as algebra tiles. So first we'll understand the notation. So this green square, if its side is x, its area would be x square. Now if you consider this blue strip, its length looks like x. Let us say its width is y units. So the area of this rectangular strip should be xy. So here the area is x square, area of this rectangle is xy, and this looks like a small square whose sides are y. So area of this small square should be y square. Now we will see one interesting property. Usually when we teach x plus y whole square, first we expand and explain, and later ask students to write this formula 10 times. Now there are many students who forget 2xy part no matter how many times they write. So this x plus y whole square is x square plus 2xy plus y square can be shown very easily with the help of manipulative. Let's see. So here x plus y whole square means I have a square whose side is x plus y. So I'll drag a model here. I will change it to be x plus y. So this length was x, so this is x. This width was y, so this much is y. So this side is x plus y. Again here we have x plus y. So area of this square is x plus y whole square, which is nothing but 1 time x square, 2 time xy, and 1 time y square. So when you show things like this, algebra becomes simple and interesting to students. Let us see one more example. Keeping the same notation, x and x area x square here, x by y area xy here, and y by y area y square here. This part will be my 2x plus 3y because it has 2x length and 3y length, and this part would be x plus 2y. So expansion of 2x plus 3y multiply by x plus 2y. The result of this, the expansion of this, should be equal to 2 times x square, 1, 2, 3, 4, 5, 6, 7, 2 times x square plus 7 times xy plus 6 times y square. Right? Now students can easily understand algebra when you use manipulatives. The idea is to introduce a concept or a property with the help of manipulative, so that in future, even if you are working with abstract symbols, students can still understand what is going on. Now this was expansion, but students face factorization very challenging, and we can gamify it with the help of manipulatives. We are giving manipulatives with our books for each and every students. So if you want to gamify the concept of factorization, you can do it. Let us consider same scenario, same manipulatives. A green square whose area is x square, a blue strip whose dimensions are x and y, so area is xy, and a small yellow square whose area is y square. Now if we want to factorize x square plus 3xy plus 2y square, first I need to gather this manipulative. So we have this x square. I'll take a copy of it and I'll drag it here. So this is my x square, this is my xy. Now I need 3 times xy, so I'll drag 3 blue strips, and this one is y square, and we have 2y square, so 2y squares are needed, so I take one more copy. So this is 1 time x square, 3 times xy, and 2 times y square. Now if I can make a square or a rectangle with it, I can have 2 brackets. and that will be my factorization. But for that you have to do trial and error. So I can arrange them like this. Now this I need to rotate. So I rotate it by 90 degree, place it here. So this is my rectangle. Now if we consider the side, this side will be x plus y and this side will be x plus 2 times y. So factorization of x square plus 3xy plus 2y square is product of x plus y and x plus 2y. Now when we teach the abstract concept, students have to split this middle term in order to factorize. So this x square plus 3xy plus 2y square becomes x square plus 2 times xy plus 1 times xy plus y square. Now here we are splitting the middle term. Now you can visualize that thing. We had 3 blue strips. We had 3 xy. We divided it in a group of 2 and 1. So this 1 xy is here. These 2 xy's are here. Students can see mathematics, and after that when you show them the method, it will be very easy for them to understand. So this is x common, x plus 2y. This part x multiplied by x plus 2y is here, x multiplied by x plus 2y, plus here we have y common, x plus 2y. So this is y times x plus 2y, and the result is this. So that's how we can show factorization with the help of manipulatives.